In question 8, the diagram shows the curves with the equation y equals to x power minus half and y equals to 5/2 minus x power half. The curves intersect at the points A and B. In part A, we have to find the area of the region between the two curves. Now, to find the area of the region between the two curves, which is basically this area, we'll have to find the area under the curve for the curve with the equation 5/2 minus x to the power half, and then subtract it from the area under the curve for y equals to x power minus half. So the area will be equals to, we'll be integrating the equation of 5/2 minus x power half, and the limits are from a till b. So the x value at b is 4 and the x value at a is 1/4, and we'll subtract it from the area under the curve of the equation x power minus half x power minus half, and the limits will be 4 and 1/4. So first integrating the first equation, that will be 5/2x, increasing the power of x power 1/2 by 1, so that will become x power 3/2, and this will divide by 3/2. And now integrating the second equation, so increasing the power of minus half by 1, so that becomes 1/2. And then when we divide this by 1/2, so the 2 will come in the numerator. So before applying the limits, we can simplify this to write it as 5/2x minus 2/3 x to the power 3/2 minus, and this will become 2x to the power 1/2. Now applying the limits over here, the upper limit is 4, so this will be 5/2 into 4 minus 2/3 into 4 to the power 3/2. And we'll subtract it from the lower limit, which was 1/4. So this will be 5/2 into 1/4 minus 2/3 into 1/4 to the power 3/2. So first simplifying this, we can first get 5. So this will become 5, 2 1 times 2 times, it will be 10. So this will be 10 minus, and 4 to the power 3/2 will become 8. So that will become minus 16/3. And this will become, so this will become 5/8. And this will become minus 2/3 multiplied by, so again 4 to the power 3/2 is 8. So this will become 1/8. Simplifying this, we'll get 10 minus 16/3, and this will be minus 5/8 minus 2/24. Now we can simplify this by taking the LCM. So this was 10/3. So this will become 30 minus 16/3 minus, taking the LCM up here. So this will become 15 minus 2/24. 30 minus 16 is 14/3, and this will become minus 13/24. And we can take the LCM. Okay, so there's not enough space left, so we'll have to just quickly simplify this. So this will multiply by 8. So 14 multiplied by 8 will be equals to 112. And 112 minus 13 is equals to 99. So this will become 99 divided by 24. So this was the area under the first curve. And now to find the area under the second curve, which was 2x to the power half. So substituting in place of 2x to the power half, first we'll substitute x equals to 4. So that will be 2 into 4 to the power half. And then we'll subtract it from 2 into 1/4 to the power half. Simplifying this, so this will be 2 into 2, which is 4, and this will be minus 2 into 1/4 to the power half will become 1/2. This will cancel out, so this will become 4 minus 1, which is equals to 3. So the final answer will be, so we can write the final answer as 99/24 minus 3. 99, so this will become 99 minus 70. 24 times 3 is 72. And then, so this will be equals to 27/24. We can simplify this answer to write it as 9/8 for the area between the two curves. So we can just make a line separating the area we found for the first curve and the second curve. And the final answer will be 9/8. And we can just, to make sure, we can just write that this will be the final answer up here. In part B, it says that the normal to the curve y equals to x power minus half at the point 1 comma 1 intersects the y-axis at the point 0 comma p. We have to find the value of p. Now to find this value of p, we first need to find the equation of the normal. Now to find the equation of the normal, we'll first find the dy dx, which will give us the gradient of the tangent. So finding the dy dx, this will be equals to minus 1 upon 2x to the power. So this will become minus 3 upon 2. We can write it as minus 1 upon 2x to the power 3 upon 2. Now, as the value of x is 1, so substituting x equals to 1 up here, we'll get 1 minus 1 upon 2 into 1 to the power 3 upon 2, which will be equals to negative 1 upon 2. So as the gradient of the tangent is minus 1 upon 2, which means that the gradient of the normal will be equals to positive 2. Once we have the gradient of the normal, we can now form the equation for the normal. So using the formula y minus y1 is equals to m into x minus x1. So this will be y minus, so the y value is 1 is equals to 2 into x minus 1. So the final equation will be y equals to 2x minus 2 plus 1, which is equals to y equals to 2x minus 1. Now, as we have to find the value of p and x is 0, so substituting x equals to 0, so y will be equals to 2 into 0 minus 1. So the value of y will be equals to 1, which is basically the value of p. So p will be equals to minus 1.